Hello guys. So today in this video I shall talk about a few questions in JEST 2022 that I think is uh, the answer given in the questions are not correct, or maybe I may be also wrong, but the answers I am getting is not matching with the answers given in the answer key. So I shall discuss mainly about these problems in today's video. So I think it may be helpful for you because you may be also of thinking of challenging these questions. So uh, you can do so. So because in JEST, uh, I think they don't take any amount to challenge. I think you have to just mail them. So it is good if you challenge few questions. Just so let us discuss about that questions now. So let me start with part C. Okay. So in part C, there is a question from thermodynamics. That is, so the question is, you have been given a PV curve. So I have solved the questions only once. So while solving it, my answer did not match. Maybe I hope this time the answer matches it. So let's solve it first. So the problem is we have an 1 mole of ideal gas which is at point A, then goes to point B. Okay, so then goes to point C and then come back to point A. So the arrow is not needed actually, it's reversible. So this is our process and it is given as 32, 32 P. This is given as P. This is V and this is 8V. So we have to find the internal energy of the gas in units of RT. Okay, while it uh, change in internal energy when it goes from A to B. So while going A to B, we have to find the delta U, internal energy. So what is the formula of internal energy? We know that CV is equal to du dt, right? So delta U will be CV into delta T. Very simple. So we have to find delta T and CV in this region. Okay. So okay. So let us do that. So what is the change? First of all, what is the change in temperature while going from A to B? And in the question, it has been given that temperature at A is given as T. So you can clearly see that while it goes from A to B, it is its pressure. I think its pressure is constant, right? So its pressure is constant while going from A to B. So we can use the ideal gas equation. What is the PV is equal to RT? You can use PV is equal to RT. You can use. So what we shall write at A, its pressure is 32 P and its volume is V and R is T is the temperature. We assume the temperature at B is T prime. So we can write from here that at B the pressure is 32 P, volume is 8V and it is R T prime. So we can now divide this both side. So 1 by 8 by dividing this with this and this, we can get 1 by T is equal to T by T prime, right? So T prime is equal to 8T. So delta T is equal to t prime minus t is equal to 80 minus t is equal to 7t. So delta t is equal to 7t. This is we have found. Okay, delta t has been found, and we have to find the answer in terms of r and t. So delta t in terms of t, it is okay. So now we have to find CV. So how do we find CV? It is also given that from A to C or C to A, this process is adiabatic. So in a adiabatic process, what is an adiabatic process? The dq is 0. So the equation of state for an adiabatic process is PV to the power gamma is equal to constant, right? So when an ideal gas obeys an goes an adiabatic process, all this is always true for an ideal gas. Okay, and when it is adiabatic, then it also follows this equation. These both equations are followed. Okay, but for non-ideal gas, this is not true. The equation of state is different there. For an ideal gas, as has been said in question, so we can use this simple equation. So let's write this at the 2 points A and C. So at point A, pressure is 32 at A. At A, pressure is 32 P and volume is V, V to the power gamma. And at at C, pressure is P and volume is 8V, 8V to the power gamma. Okay, so this follows from there. Oh, sorry, here. Okay, so now we have to find gamma. So we can eliminate V from here. So 32 and PV to the power gamma is equal to P. I can cancel P. Okay, I can cancel P. And okay, so cancel P from here, and we can write 32 V to the power gamma as 2 to the power 5 into V to the power gamma is equal to 8 is equal to 2 cubes. So 2 to the power 3 gamma into V to the power gamma. I think it is okay, right? Because 2 to the power 5 is equal to 32, I think, and 2 to the power okay, okay, 2 to the power 5 is equal to 32 and 2 to the power 2 cube is equal to 8. So what is now for it is cancelled, and clearly 3 gamma is equal to 5. So gamma is equal to 5 by 3. So you have now your gamma, and you know Cp minus Cv is equal to R, and Cp by Cv is equal to gamma. So you can Cp is equal to gamma Cv. So putting this here, you get gamma minus 1 Cv is equal to R, and so what I get now is 5 by 3, 5 by 3 minus 1 into Cv is equal to R. So R 2 by 3 Cv is equal to R, or Cv is equal to 3 by 2 R. Okay, this is our Cv. So now simply now put Cv and delta T in this equation. So this gives us delta U is equal to Cv into delta T, which is given as 3 by 2 R into delta T is 7T. We earlier found delta T is equal to 7T. Yes. So the answer is 21 RT by 2 is equal to 21 means it is 10.5 RT. So this is the answer I am getting. So I don't know if it is correct or not, but this is what I am getting. Okay, and the answer given is 17.5. So, if any one of you have got this answer correct, please let me know where I have done any mistake, or maybe I have done it right. So just let me know if you have got the same answer or not. So this is the one question in part C. So there is another question in part B. So it is part B. Uh, the question was like, there is a particle and a laser of power P is incident on the particle. So which was initially at rest, and it completely absorbs the radiation. So the kinetic energy of the particle we have to find as a function of time. So uh, if you have read electrodynamics, then you must know that the pressure exerted is equal to, I don't know, my pen is not working correctly. So okay, so pressure exerted is P, the power by C, when the radiation is completely absorbed. Okay, so it is the pressure exerted by a radiation, or the radiation pressure, we know the radiation pressure, the radiation pressure. Okay, and so the radiation pressure is this. So the we have to find the kinetic energy. So the force, the pressure is actually the force by area is equal to P by C. Actually, this, when we say this is as power, actually this is actually the power per area. Actually, this is actually power per area. So you can write it as P prime. So according to the question, uh, in question it is given as total power. So P is equal to P prime into A. Okay, so it is the total power. So we can write it by P prime is equal to P by A, and we can cancel A, and force is actually powered by C on the particle. Okay, so when we now we know the force on the particle, we can simply use the Newton's equation of motion. It is mv double dot is equal to force is equal to P by C. So you can, sorry, mv, not mv double dot, is mv dot. So mv is equal to pt by c plus some constant k, but it will be zero, as it has been said the particle starts from rest. So at t is equal to zero, its velocity will be zero. So the constant will go to zero. So v is given as pt by mc. So its kinetic energy will be half mv square is equal to half into m into p square t square by m square c square is equal to p square t square by 2m c square. Okay, so this is the kinetic energy. So this is the kinetic energy I am getting. But in question it has been given as half pt into pt by mc square plus 1. So actually I don't know how this plus one term comes, but this is actually unphysical, what I think, because suppose a situation of a particle where m is very large, m tends to infinity, very large mass, a particle of very large mass. Okay, then what this formula says, when m is small, m is very large, so this term will go to zero almost. Okay, it will be very small compared to one. Okay, but what this term says is, even if the m is very large, so its kinetic energy will be half pt. So actually, even if the particles mass very large, so its uh, its kinetic energy increases linearly with time. So this is unphysical, right? So when the particle mass is very large, when it is infinite, it should always remain at rest. So this is the limiting case we have to assume. So when the particle is very large, you cannot move it by any finite force. This is logical, right? But it says its kinetic energy will increase linearly with time. So this is very fast actually. Okay, so linear in time, it's very fast. So even if it was some small decaying function of t, I may may uh, accept it, but I don't think it is an acceptable, it is a physical answer. So maybe I may also be wrong here, but I think it should be the correct answer. So let's move on to the second question. So another question was from, it was from part A. So part A, this question I have solved already earlier too. So, but I don't know how. Okay, so how the answer is different here. So the question is p of x is given as 4v naught into 1 minus x into x, while x is less than equal to 1 and greater than is equal to 0 and infinity otherwise. So its potential graph will look like what? Between 0 to 1, because we have to find the wave function between 0 to 1. It has been given in the answer. So at 1, at x is equal to 0, it is 0. At x is equal to 1, it is 1. You can also, so the wave function will look like, the potential will look like this. And now you have to plot the wave function. So you have to know one thing, that when the potential goes high, the probability goes low. So the wave function's amplitude has to be low there. And another thing is that when uh, and with the increase of potential, the frequency, I mean, if the wave function is oscillatory, the frequency will also increase. Okay, so actually the graph would look like, you start from 0, this there is, at the as the potential is increasing, the frequency should also increase, but the amplitude should decrease. Okay, so now this should be the graph. I don't know, they have given this kind of answer, so there is no change of frequency, and here it is constant. I don't know how it comes. So this should be the answer. Okay, I think this should be the answer. So I don't know if how that comes. Okay, but please let me know what you think about it. Okay, so and another question was, yes, it was also quite shocking for me actually. Uh, the probability density of the hydrogen atom. So the wave function was, we all know it is some constant into e to the power minus r by a naught, and we have to find the probability. And the probability is, what is probability? Probability r is, it is the integration of r square into mod of psi square into dr, where the theta and phi integration has been done. Okay, so if you plot only p of r, so you just plot this function. So r square, you have to plot r square into e to the power minus 2r by a naught, and the graph should look like this. And but the answer is given as this. I don't know uh, what how that makes sense. So maybe I am missing something, but it looks trivially easy for me, but I don't know what can be done. Okay, so I think these are few questions that I think is controversial this time. The answers I am getting is not. So I am telling again and again that I may also be wrong, because before telling that the answer key is wrong, I think I may have to check few more points. Maybe I am missing few concepts in any questions. So the answers I am getting is different. So you just check with others that what they are saying. This is my thoughts in in these questions. So if there are any more questions, please let me know in the comment section. I shall also I shall also discuss these questions too. So okay, goodbye for now.